Good evening, back with our class today. So today we will study about VBT in coordination compounds. We have to talk about VBT in coordination compound. VBT in coordination compound is valence bond theory in coordination compounds. Before that, we will revise back what all we studied. We studied Werner's theory of coordinate bonding. In Werner's theory, we studied that every metal atom in a complex ion has got two kinds of valencies. One called as its primary valency and the other called as its secondary valency. The primary valency corresponds to its oxidation state and is ionizable, and the secondary valency corresponds to its coordination number and is non-ionizable. The metal atom tends to satisfy both its primary valency as well as its secondary valency. Negative ions can satisfy both its primary valency as well as its secondary valency. The secondary valencies are a fixed number and are called as what? Its coordination number. They are arranged around the metal atom in a fixed or a definite manner, giving a particular geometry, and that is called as what? Coordination polyhedron. For a coordination number 6, it is what hedral? Octahedral. For coordination number 4, it is either square planar or tetrahedral. For coordination number 5, it is trigonal bipyramidal. Then we studied something which is called as what? EAN. What is EAN? Effective atomic number. It says that the metal atom keeps on taking electrons from the ligand until and unless it reaches the next noble gas configuration. What is the formula of EAN? Z minus X plus Y, where Z is atomic number, X is oxidation state, and Y is the number of electrons it takes from the ligands. Now write merits of Werner's theory. Merits of Werner's theory. 2 marks question in board, merits and demerits of Werner's theory. So first, merits of Werner's theory. First thing, then only after we study the demerit, we will talk about VBT. Okay, so we'll complete the demerit and then go to VBT. Please write, explains the formation of complex ions. Werner's theory explains the formation of complex ions. Second, it explains the geometry of complex ions. It explains the geometry of complex ions. Third, it differentiates between primary and secondary valency. It differentiates between primary and secondary valency. What these three are the merits of Werner's theory. Clear? Werner's theory talks about the formation that it takes the central metal atom or the ions take electron from the ligand and thus has a complete fixed formula depending upon its coordination number. It makes a wide difference between its primary valency, which is ionizable, and the secondary valency, which is non-ionizable. It also talks about the geometry because it talks about the coordination number and the arrangement of ligands around the central metal atom or ion. If it is coordination number 6, its geometry will be octahedral. If it is 4, it will be either tetrahedral or square planar. If it is 5, it will be trigonal pyramidal. Correct? Now write demerits. Demerits of Werner's theory. Please write, it fails to explain why only some elements can form complex compound. It fails to explain why only some elements can form complex compounds. Why only some elements can form complex compounds. We only form complex compounds with what series? 3D series. Okay, we study compounds only as scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So it fails to explain why all the other elements such as p block element and s block elements do not end up forming what compounds? Complex compounds. Right, next point. It fails to explain the magnetic and optical properties of complex compound. It fails to explain the magnetic and optical properties of complex compound. What do we talk about magnetic properties? By Werner's theory, I can explain whether it is paramagnetic or diamagnetic. Can I explain? No. Can I explain anything about its electrical property or whether it will conduct electricity? See, if it is a paramagnetic compound, it will conduct electricity because there is movement of electrons. If it is a diamagnetic compound where the electrons are paired, the electrical conductivity is less. Same way, if there is a single electron, it shows optical property that it shows color because the single electron will get excited to higher energy level by absorbing a certain part of the spectrum of the white light, and then when it jumps back to its original state, when it comes back to its original state, it gives back its complementary color. So neither can I explain about its magnetic property, whether it is single, that is paramagnetic, or whether it is paired, that is diamagnetic. Nor can I explain about the color in a complex compound, which is what property? Optical property. Correct? The third point. It fails to explain the directional property of coordinate bond. It fails to explain the directional property of coordinate bond. Does it basically explain that is the metal atom is forming a bond from the metal to the ligand or from the ligand to the metal? Can we see it? We do not see it. We just draw arrows which are not directional. Don't we draw our bonds like this, which does not show when I draw bond. So I write NH3 like this. Is this giving an electron or is it giving an electron? Can it be explained when I see it? I cannot explain. So what are the three demerits? First demerit is that it basically I am not able to tell why only D block element form complex compounds. Second, I am not able to explain the magnetic property and the color or the optical property of a coordinate compound. I can even not explain the directional nature of the coordinate bond, whether it is a ligand metal bond or it is a metal ligand bond. Clear? So, to remove all these effects, we study what? VBT. What are the three different theories of coordinate compound we will study? First we will study VBT. Then we will say this is not correct. Then we will study CFT. Then we will say this is also not correct. And then we will study LFT. LFT is not in our syllabus. Okay, so what are these small words? VBT, valence bond theory, talks about hybridization. Crystal field theory, and this is ligand field theory. So the three most important theories related to the explanation of complex formation or coordinate compounds are VBT, CFT and LFT. What we follow now is LFT, but what we will study is VBT and CFT. Okay, what is VBT? Valence bond theory. What is CFT? Crystal field theory. What we follow presently? Ligand field theory. Okay, but we will study only VBT and CFT. Is it clear? So three theories related to the formation of coordinate compound are ligand field theory, which we presently follow, CFT, which explains the magnetic and optical properties beautifully, and VBT, which basically gives you the hybridization and the geometry of a complex compound. Clear? Gota gota? VBT, hybridization and geometry. Even it tells about its magnetic property, whether it is paramagnetic or diamagnetic. CFT explains about its optical as well as magnetic properties. And LFT talks about all, but it is not in our purview of syllabus. Clear? So right. First, VBT. Valence bond theory of coordinate compound. To remove the defects of Werner's theory, we study what? VBT. VBT is what? Valence bond theory given by Pauling. Linnaeus Pauling. VBT was developed by Linnaeus Pauling, I think in 1931, but Linnaeus Pauling in 1931. A date now once check ಮಾಡ್ಕೊಳ್ಳಿ, not important but still. Okay, so write postulates of VBT. Postulates of VBT. First point, in a coordinate compound, the central metal atom provides definite number of vacant orbitals. Central metal atom provides definite number of vacant orbitals for the formation of coordinate bonds started. Fine. In a first point, in a coordination compound, the central metal atom provides definite number of vacant orbitals for formation of coordinate bond with the ligands. Bardidira? Second point baridi. Under the influence of strong ligands, like Cn minus NH3 CO, under the influence of strong ligands such as Cn minus is what? Cyanido. What is NH3? AMMINE. What is CO? Carbonyl. In the presence of strong ligands like Cn minus, NH3, etc., the unpaired electron present, don't write, for you both, okay, write completely. The unpaired electrons present in the central metal atom or ion, are forced to pair up against the Hund's rule. And this is called as spin pairing or forced pairing. It is called as what? Spin pairing or forced pairing. So let us understand what we have written. don't write the example. I am just trying to explain it to you. What is spin pairing or forced pairing? Let us take the complex FeCN6 4 minus FeCN6 4 minus. Okay, so or I can take the complex K4 FeCN6 neutral complex, which is called as what? Potassium hexacyanidoferrate 2. This is the complex. Now I have to find out the hybridization in the central metal atom Fe. How do we find out hybridization? We generally write its oxidation state. Okay, or we generally write its atomic number. So what is the atomic number? 26. What is its valence shell configuration? Argon 3d6 4s2. Correct? Isn't it? It is argon. Don't write, I'll explain. Argon 3d6 4s2. So what exactly have I tried? If I write it like this is my d orbital, 5 d orbitals, dxy, dyz, dxz, dx square minus y square and dz square. Then I have 2 electrons in the s. 6 means I have 1, 2, 3, 4, 5 and 6. While filling the d orbital, I followed what rule? Hund's rule. Each orbital will be first having 1 electron and then only pairing takes place. And then I have what? 4s2. This is called as what configuration? Ground state configuration. Correct? Now, ion is in what state here? Fe plus 2. If it is in Fe plus 2 or in an excited state, so what is its configuration? Argon 3d6 4s 0. These 2 electrons have now been vacated from the 4s. So how will I draw 3d6? Again, I will draw it like 1, 2, 3, 4, 5, 6. Okay, so this is in accordance to what rule? Hund's rule. But the moment I use a strong ligand like Cn minus, this pairing, which is according to the Hund's rule, is skipped. And how does it pair? It pairs in the form not following the Hund's rule. So how does it pair? 1, 2, 3, 4, 5, 6. This kind of pairing, which takes place in presence of a strong ligand, is called as what pairing? Spin pairing or forced pairing. The moment it happens, I get 2 empty d orbitals for electrons from the ligand. So this is the second postulate. Did you understand? This is how the normal hybridization goes. But the moment it takes place in presence of a strong ligand like Cn minus, like NH3 or in presence of CO, immediately what takes place? Forced pairing takes place. Pairing against the Hund's rule. That means it will not have 1 electron each. It will start pairing from the first only. As a result of it, this pairing is called as what? Forced pairing or spin pairing. End out of Pritam.
How are there 6?
How are there 6 electrons?
6 Cn.
Huh?
If Cn becomes 2 1.
Did I talk about that?
No.
I am talking about what?
Where is the space?
Huh?
The space.
The space. Let me hybridize. Have patience ना यार. अभी मैंने सिर्फ रोटी बेला है. तू पूरा समोसा खा लिया यार. Have patience. We have just taken iron now. I have to make empty orbitals. How many empty orbitals? 6 empty orbitals. So from where will I get 6 empty orbitals? 2d, 1s and 3p. So what will be my hybridization? d2, sp3. Further stage. Only the second point to explain. Did you get what is forced pairing or spin pairing? It is pairing against the Hund's rule. Each orbital will not have 1 electron each, but it will pair first. Okay? Now, third postulate, Barili. The number of vacant orbitals the number of vacant orbitals provided by the central metal atom or ion, the number of vacant orbitals provided by the central metal ion is equal to its coordination number, is equal to its coordination number. Okay, now let us understand this part. Now what is my coordination number? 6. So I require how many empty orbitals? 6 empty orbitals. So from where do I get? I have this as 3d6. What is the next orbital? 4s. What is the next orbital? 4p. So I have 1s and 3p orbitals. So see, 1, 2, 3, 4, 5, 6. 6 orbitals are there. So this will detach from the D and these all will fuse together to form a new orbital with 6 vacant orbital, and this is called as what? D2 sp3 hybridization or hybrid orbital. Is it clear? The coordination number and the vacant orbital should be the same. Now what we will do? This empty orbital will now take and have electrons of the ligand, and that is how it will become paired. Understood? So 6 Cn minus will give each a pair of electrons. So total number of electrons, how many? 12 electrons which are accommodated. I have shown the metal electron by arrows. I have shown the ligand electron by cross. So these are the electrons donated by the ligand. These are the electrons of the original metal atom. Clear? Understood? So the coordination number should always be equal to the number of vacant orbitals. If it is a tetrahedral complex or 4 coordination number, how many orbitals should fuse? 4. Clear? So it can be sp3 hybridization or it can be dsp2 hybridization. Clear? Please write. These vacant orbitals, next point, these vacant orbitals undergo hybridization to form new equal number of identical hybrid orbitals. Next point, the hybrid orbitals of the metal ion, overlap with the filled orbitals of the ligand, to form coordinate bond between the metal and the ligand. Next, very important point, the geometrical shape of the complex. Depends on the type of hybridization. The geometrical shape of the complex depends on the type of hybridization. Please write. First, dsp2 hybridization. If it shows dsp2 hybridization, the shape is square planar. hybridization. The shape is tetrahedral. Okay, if it shows D2sp3 hybridization, the shape is octahedral. Ulta also is octahedral. sp3d2 is also octahedral. D2sp3 is also octahedral. dsp2 is square planar. sp3 is square planar. These two are for coordination number 4 and this is for coordination number 6. Is it clear? If the coordination number is 4 and it shows the sp2 hybridization, the shape is square planar. If the coordination number is 4 and it shows sp3 hybridization, the shape is tetrahedral. If the coordination number is 6 and it shows D2sp3 hybridization or sp3d2 hybridization, the shape is octahedral. So the geometry of a complex ion is fixed by the type of hybridization it shows. Okay, the last point please write. When a complex ion or a compound, when a complex compound contains one or more unpaired electrons, one or more unpaired electrons, it is paramagnetic in nature. It is paramagnetic in nature. If it does not contain unpaired electrons, if it does not contain unpaired electrons, it is diamagnetic in nature. ಇದು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲೂ ಓದಿದ್ದೀರಾ. ಡೊಮೇನ್ಸ್ ಅಂತ ಹೇಳ್ಕೊಟ್ಟಿರ್ತಾರೆ, ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್, ಫೆರಿಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂತ, which is deleted from your syllabus but it exists. So if there are unpaired electrons, it is paramagnetic. If there are paired electrons, it is diamagnetic. Fine. So this is the postulates of VPT, which comes for how many marks? 2 to 3 marks. Okay. But in all PU board, even in CBSE, postulates are generally not asked, but a compound is asked and they ask you to find out the hybridization. It is a 4-mark question in both. Sometimes 3+2 or 4+1. Logical kelirtare. Generally in CBSE it used to be a complex compound, 1 mark naming and 1 mark was isomerism till now. But now isomerism has been removed. For PUC student, it was always in part D of inorganic chemistry, 1 question on one of this, 1 question from CFT, which we will study later. 1 on octahedral or if that complex, VBT octahedral kelidre, tetrahedral keltare, CFT. Both, so both should be read properly. Yen bitrenu coordination compound ali naming bidbardo and e compounds bidbardo. Okay, ನಿಮಗೆ 4 compounds ಕೇಳ್ತಾರೆ for PUC, for CBSE, including this 4, something else also may be asked. So please write applications of VBT to octahedral complex. Amog and Preetham was right. Applications of VBT to octahedral complexes. Applications of VBT to octahedral complex with coordination number 6. Applications of VBT to coordination compound, coordination number 6. First thing, right, show the hybridization. And question barutte helkodta idini. Show the hybridization and geometry and magnetic properties and magnetic properties of complex ion CONH3 whole 6 plus 3. CONH3 whole 6 plus 3. Fine? Understood this? So we have to explain in this what is its hybridization. So we will know hybridization, either it will be sp3d2 or it will be d2sp3. What is the shape? The shape will be octahedral. Whether it is paramagnetic or diamagnetic. Whether it is an inner orbital complex or an outer orbital complex. If it is paramagnetic, it is high spin complex. Because if it is paramagnetic, it is influenced by magnetic field. So it is what complex? High spin complex. If it is diamagnetic, its spin momentum cancels or spin quantum number cancels each other, minus half and plus half. As a result of it, it will be what? Low spin complex. So yavagladru ee tara octahedral complex kotre enen baribeku? Its hybridization, its geometry, whether it is paramagnetic or diamagnetic, whether it is inner orbital complex or outer orbital complex, whether it is high spin complex or low spin complex. So depending on this only your mark distribution is done. Okay? So whenever a complex compound is given, these are the things you should write. First, hybridization. Second, geometry. Third, magnetic properties, whether it is paramagnetic or diamagnetic, whether it is inner orbital complex or outer orbital complex, high spin or low spin. If it is paramagnetic, it is high spin. If it is diamagnetic, it is low spin. If it is getting as d2sp3, penultimate d orbital is utilized, then it is what complex? Inner orbital complex. If an outer d orbital is involved, sp3d2, then it is called as what complex? Outer orbital complex. First d bandre inner orbital, last d bandre outer orbital. Either inner orbital means d2sp3, outer orbital means sp3d2. Why it is called inner orbital? Because an inner d is used. That means 3d, 4s, 4p. Then it is what complex? Inner orbital complex. Outer orbital complex is 4s, 4p, 4d is used. Then it is called as what complex? Outer orbital complex. Artha inner orbital and outer orbital. Now let us try to understand. The first one I will dictate and tell you how to write. From second onwards you can write on your own. Please write. The central metal atom in this complex is cobalt. Is cobalt. Right? Its atomic number. Its atomic number is
27.
Iron is 26, cobalt is 27. Okay? Right. Electronic configuration of cobalt is. Next, electronic configuration of cobalt is. Why I am dictating this is the way you are supposed to write to get full marks in this. And one question will be pakka there out of the 4 we do or something similar to it. Cobalt is what? Argon, 3d7, 4s. Electronic configuration of cobalt is 3d7, 4s2. We will even involve what? 4p. So write it off here only. 4p, 0. 3d7, 4s2, 4p, 0. Which state is this? It is ground state electronic configuration. ನಾನು GS ಬರ್ದಿದ್ದೀನಿ, ನೀವು ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಬರೀರಿ. Right. Electronic configuration of CO plus 3. Electronic configuration of CO plus 3. Why CO plus 3? Because NH3 is what ligand? Neutral ligand. So cobalt has got an oxidation state of plus 3. So electronic configuration of CO plus 3 is what? Argon. 3D. Esto 2 and 1. So it becomes what? 3D6, 4S0, 4P0. 3D6, 4S0, 4P0. Which state? Excited state. Barili. Then barili. Orbitals of CO plus 3 ion. Orbitals of CO plus 3 ion. I am rubbing this part to write orbitals of CO plus 3 ion. How do we write the orbitals? We have what orbitals? 3D6. So we will write first R3D6. 1, 2, 3, 4, 5, 6. We have this as 4S. We have this as 4P. Please write 4P, 4S and 3D. 3D6, 4S, 4P. Fine. Then write in presence of strong ligand NH3, in presence of strong ligand NH3, the d electrons undergo pairing against the Hund's rule, pairing against the Hund's rule, and this pairing is called as forced pairing or spin pairing, and this pairing is called as forced pairing or spin pairing. Barili. Forced pairing in CO plus 3 ion. One, 2, 3, 4, 5, 6. Then you have 4S and you have 4P. Correct? Right. Forced pairing in CO plus 3. Then write the empty orbitals. Inge mark ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ ಇಲ್ಲಿ. The empty orbitals show D2sp3 hybridization. The empty orbitals show D2sp3 hybridization. Done? Written? Now write. ಮತ್ತೆ ರಬ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಬರೀರಿ. D2sp3 hybridized orbital of CO plus 3 ion. D2sp3 hybridized orbital or hybrid orbitals of CO plus 3 ion. What is it? We have 3 orbitals of D. And then we have a big orbital D, S and P. Okay, so this is what hybridized orbital, D2 sp3 hybridized orbital. D2 sp3 hybridized orbital. Artha aita madirodu? We have taken out these two of D and this is one S and these are 3p orbital forming D2 sp3 hybridized orbital. Right. The ligands donate a pair of electrons which are accommodated in the 6 vacant hybrid orbitals forming 6 coordinate bond. Forming 6 coordinate bonds. Bariri CONH3 whole 6, CONH3 whole 6 plus 3 ion. These are the electrons donated by the ligand. You can even draw it in the form of electrons if you are using the pencil and a pen or a blue and a black pen, because I don't have anything to show. I have used it as crosses, but you can even draw the same thing here, but you can draw it more darker or something like this. So these are the electrons donated by the ligand. Understood? You can draw like this, one blue pen, one black pen. So these are the electrons which are donated by the ligand. Bariri 6 pairs of electron. Idhar kelgade bariri 6 pair of electrons from 6 NH3 molecule. 6 pair of electrons from 6 NH3 molecule. Artha aita how to write? First thing, you will write the central metal atom, then you will write its ground state, its atomic number, its ground state configuration, its excited state configuration. You will say in presence of a strong ligand it shows what pairing? Spin pairing or force pairing. You will pair it up. Empty orbitals you will show hybridization. Then you will divide them and show the empty hybridized orbital. Then you will say the ligand donate the electron in these empty orbitals, and this is how it finally looks. Clear till here? Now write. Thus, CONH3 whole 6 plus 3 shows A. What hybridization does it show?
D2 sp3.
Right. It shows, now I am writing what all you have to write. Shows A D2 sp3 hybridization. B, its geometry is what? Octahedral. Third, are all the electrons paired? In the final CONH3 all 6 plus 3, are all the electrons paired? Yes. So it is what complex? It is diamagnetic, as all electrons are paired. As all electrons are paired, it is diamagnetic. Which d orbital is used? Pen penultimate d orbital, 3d orbital is used. So it is what complex? Inner orbital complex. Mariri. It is an inner orbital complex as an inner d orbital is used. As an inner d orbital is used. Is it low spin or high spin? Low spin complex. Next point, Barili. As all the electrons are paired, it is low spin complex. It is low spin complex. Is it clear what we did? This is how you are supposed to write for 4 marks, everything. So you should have 5 things: hybridization, geometry, magnetic behavior, inner orbital complex, and it is low spin complex. As you do many compounds, you will get an idea. The moment it is diamagnetic, it is mostly an inner orbital complex, and most of the inner orbital complexes are also low spin complexes. Now try showing in the next one, which you will write. Please write. Show hybridization. Yenama?
What about sp3? Inner orbital or sp3?
Is the d orbital important? Then why? If the d orbital is not involved, then it will be neither an inner orbital nor an outer orbital. And did I teach tetrahedral complex? Where does sp3 come? Did I teach coordination number 4? Abhirupja. Have patience. Please write. Show hybridization. When I said give, that time nothing happened. Show hybridization, geometry, and magnetic property in FeCN6 4- ferrocyanide ion. FeCN6 4- or ferrocyanide ion. Please don't skip steps, because it is required that you write in the same format. Illidre marks kodalla. Particularly Preetham and Amol, don't skip steps.
Can we write it in like
Huh?
Z of FP?
Huh?
Z of FP.
Yeah, in atomic number of F. So 2 examples or 3 examples of compounds in which we used what ligand? A very strong ligand, and we did what pairing? Force pairing or spin pairing. Now we will study a complex which is COF6 3-. What is the name of the compound? Hexafluoridocobalt. Cobalt or cobaltate? Cobaltate. Hexafluoridocobaltate. Now what is the oxidation state of cobalt? X minus 6 is equal to minus 3. So X is equal to minus 3 plus 6. So X is equal to plus 3. So what is the name of my compound? Hexafluoridocobaltate 3. I am not writing in detail. First listen, then you can write. So now I have to show hybridization, bonding, or rather hybridization, geometry, and magnetic behavior. Whether it is an inner orbital or outer orbital complex. So first thing, what is my central metal atom or ion? Cobalt. What is its configuration? 27. If it is 27 means what? Argon, 3d7, 4s, 2, 4p, 0. Correct? Now, when it is in what state? CO plus 3 state. What will be its configuration? Argon, 3d6, 4s0, 4p, 0. Correct? 4p ಜೊತೆಲಿ ಅದರಲ್ಲಿ ಇನ್ನೇನು ಇರಬಹುದು? Next orbital is what? 4d. But we will not talk about it now, but we will see how it is possible. So now I will write its configuration of 3d6. not show any force pairing or spin pairing. Now it requires how many orbitals? 6 orbitals. But I have empty how many orbitals? 1, 2, 3, 4. So it goes to the next higher d orbital. What is my next higher d orbital? 4d orbital. And takes from 4d orbital, what it takes? Only 2 of them. And hence forms hybridization as what? sp3d2. If it is a weak ligand, it does not show force pairing or spin pairing. So it will now take the help of these further orbitals. So we are using what orbital now? 4d orbital, outer d orbital. So it will be what complex? Outer orbital complex. So how will I write the orbital concept of COF63 minus 1, 2, 3, 4, 5, 6. Then I will add all this up. What will I add? S, P3 and D2. 1, 2, 3, 4, 5, 6. What is this hybridized orbital called as? sp3, D2. Now, electrons of ligands will come and fill. So what is this complex? First, what hybridization? sp3, D2. What is the shape? Octahedral. What kind of a complex is it? Paramagnetic. Whether it is a low spin complex or high spin complex, as there are many electrons which are unpaired. Which kind of a complex is it? Inner or outer? Outer orbital complex. Is it clear? Understood? So you will get only these complexes. What? CONH3O6 plus 3 and COF63 minus PUC. ಇದು ಎರಡೇ ಬರೋದು. ನಿಮಗೆ ಬರ್ಬೋದು FeCN6, FeCN6 3 minus. You should even try doing FeH2O whole 6 plus 3. This is again your homework. Okay, now I want to ask, will you come tomorrow for tetrahedral complexes? ಬಂದು ಮುಗಿಸ್ಕೊಂಡು ಬಿಡ್ತೀರಾ ಈ ವಾರ or next week ಮಾಡಲಾ? Next week.